The number one engine on this list uses a Bosch mechanical injection pump, zero-emissions hardware, and an engineering margin so deliberately oversized that its stock connecting rods can survive 1,400 horsepower in built drag applications. We're talking about an engine where the factory truck operates at maybe 15% of the rotating assembly's actual mechanical capacity. That isn't a marketing claim. That's a design decision somebody made in a Cummins engineering office in the late 1980s, and it's the reason a specific generation of diesel pickup is still crossing 1,000,000 miles today on the original block. Today, we're ranking 10 diesel engines that prove their durability, not in controlled lab testing, not in manufacturer press releases, but in documented, photographed, real-world mileage logged by owners who had no reason to lie about the numbers. And by the end of this video, you'll understand exactly which diesel architecture actually goes the distance, why some of the newest and most expensive diesels on dealer lots today are failing at a fraction of these numbers, and the one specific design omission that separates the engine at number one from everything built since. Stick around for it, because most of what the automotive press has told you about modern diesel longevity has the cause and the effect backwards.
Number 10. The Volkswagen 1.9-liter TDI. Here's something that will irritate every truck guy in the comment section. One of the most indestructible diesel engines ever built doesn't live under the hood of a heavy-duty pickup. It doesn't power a semi. It doesn't haul triple-digit tons across a mountain pass. It lives in a Jetta. The Volkswagen 1.9-liter TDI, specifically the ALH engine code produced from 1998 through 2003, is a diesel so well engineered that a shop in Canada tore down an ALH with 720,000 kilometers on the clock and reported the internal wear was minimal, on an engine that some owners hadn't even maintained religiously. 90 horsepower and 155 pound-feet of torque, numbers a modern diesel laughs at on a spec sheet. But here's the engineering detail that actually matters. The cast iron block has a thermal expansion rate that nearly matches its aluminum head, which is the specific reason these stay sealed under decades of heat cycles that would destroy lesser head gaskets entirely. The Bosch rotary injection pump is bulletproof when fed clean diesel. There's no high-pressure common rail to crack, no piezoelectric injectors that drift out of calibration, no diesel particulate filter to clog. Highway fuel economy runs in the low to mid-40s in miles per gallon, which is still competitive with hybrid sedans built 2 decades later. On the Grassroots Motorsports Forum, a 1999.5 Golf TDI owner posted, "My Golf two-door TDI 5-speed has been a trooper and never left me stranded. I've got just over 230,000 on it and drive it 150 miles a day. That isn't a special case. That's a Tuesday for an ALH." Dieselgate poisoned the TDI brand in 2015. But what Martin Winterkorn's software team did to emissions certification software had absolutely nothing to do with the engine block does mechanically. The ALH had already been out of production for 12 years when that scandal broke. The engine never lied about anything. For anyone shopping used vehicles in 2026, a documented ALH TDI with service records represents one of the most rational buys in the market. A proven longevity ceiling that most newer vehicles can't honestly claim. Number 9. The Land Rover 300 TDI. Land Rover has a reputation that is, to put it charitably, complicated. The brand wraps agricultural engineering in aspirational mythology and charges premium prices for the combination. But buried inside the Defender and the Discovery, before the lifestyle reboot, before the aluminum monocoque, back when Defenders were farm equipment with a windshield that sometimes fogged, there lived an engine that deserves far more recognition than it gets from the automotive press. The 300 TDI is a 2.5-liter direct injection turbocharged four-cylinder fitted to Defenders and Discoveries through most of the 1990s. About 111 horsepower on a good day. By modern standards, that figure looks like a typo. By the standard of an engine designed to start on the third turn of the key in a Welsh farmyard in February at -6 degrees, it's exactly the right number. The mechanical architecture is what sets it apart. Iron block, straightforward direct injection without the high-pressure common rail systems that create expensive repair scenarios in modern diesel applications. A design philosophy borrowed from commercial vehicle engineering rather than from passenger car cost reduction. There's no diesel particulate filter on this engine. There's no AdBlue tank. There's no dealer software required to read a fault code because there are very few fault codes the engine can throw in the first place. On Land Rover forums, owners routinely discuss examples in the 300,000 to 400,000 mile range as ordinary experiences, not bragging rights. One member on the Single Track World forum, noting their vehicle's mileage, commented simply, "If it's had regular oil services and the required cam belt changes, this is about 30% of its possible life." That was a casual remark about a decades-old engine. The timing belt is the single item that demands genuine discipline. Miss that interval and you'll learn what an interference engine does when the belt snaps at speed. Replace it on schedule, do the oil changes, address the head gasket if it ever complains, and the 300 TDI will outlast the chassis it's bolted into. Its reputation in global markets is earned precisely because it accumulated that reputation in environments where failure genuinely wasn't an option.
Number 8. The BMW M57 3.0-liter. BMW builds some genuinely great engines and some genuinely catastrophic ones. The N47 timing chain failures and the N63's structural oil consumption issues make clear that Munich's engineering culture has its expensive off days. But the M57 turbo diesel inline-6 sits firmly in the great column, and it doesn't get the credit it deserves in North American conversations because most Americans never had the chance to drive one in a car they actually wanted. Produced from 1998 through 2013, the M57 in 3.0-liter form powered the 3 Series, the 5 Series, the X5, the 7 Series, and the Range Rover Sport. In some markets, the 2008 BMW 335d made 265 horsepower and 425 pound-feet of torque, 0 to 60 in 5.7 seconds in a diesel in 2008. That isn't supposed to be possible according to anyone who hasn't actually driven one. BMW's own engineering team rated the M57 to last 600,000 kilometers, 372,000 miles at factory design load. That's the conservative corporate estimate, not the forum brag. On BMW forums in the UK, one owner running 3 different M57-powered cars posted, "I love the 6-cylinder M57 units and they're widely regarded as bomb-proof. Owned nearly 18 years now, done just over 200,000 miles, 160,000 of them with me. It's had 1 injector, 6 glow plugs, and a radiator." Think about that. 18 years of ownership. 1 injector, 6 glow plugs, and a radiator. That's the entire intervention list. The known weak points are real and worth saying clearly. The intake manifold swirl flaps can break and get ingested into the cylinders if you ignore them, so smart owners delete them proactively. The EGR cooler can develop internal leaks. The diesel particulate filter on later versions requires sustained highway driving to regenerate properly, which is why short-trip city use destroys M57s while highway commuters cross 500,000 kilometers without trouble. The engine isn't the problem. Asking it to do the wrong job is the problem.
Number 7. The Detroit Diesel Series 60. When Detroit Diesel launched the Series 60 in the late 1980s, the rest of the industry was still debating whether electronic injection was a viable commercial bet. Detroit didn't debate.
They designed a completely electronic unit injection system, put it in production, and executed it correctly on the first serious commercial attempt. The 11.1-liter and 12.7-liter inline-six versions became the backbone of American long-haul trucking through the 1990s and into the 2000s. Fleet managers who tracked their numbers properly, who actually logged cost per mile rather than guess at it, found the same pattern again and again. Series 60s ran longer between major overhauls and cost less per mile to operate than most direct competitors. 1,000,000 miles before a major rebuild became the standard expectation for a properly maintained Series 60, not the exception. On the Bob is the Oil Guy forums, one trucker posted, "I dropped a factory reman 12.7-liter Detroit 60 in my 2013 Freightliner. I'm at 978,000 miles on it now. It has never come close to the ad mark on the dipstick over an oil change period. Samples always look good. Nearly 1,000,000 miles, oil consumption essentially zero. That's the standard the Series 60 set and the standard most modern diesels can't approach." Here's the caveat that matters, because it's the same caveat that will keep appearing on this list. The EGR system added in later production years to satisfy tightening federal emission standards eroded that legendary reliability record. The pre-EGR Series 60s are the ones that built the million-mile reputation. The post-EGR versions are the ones that taught fleet managers what an EGR cooler failure does to a head gasket. Same engine block, different supporting cast, different outcomes. Before we get to number 6, here's a preview of where this list is going. The number 1 engine has 0 electronic fuel control components, not one, and that single design decision is the main reason a Cummins Forum member's 1991 work truck reached 1.3 million miles without opening the engine. Keep that in mind. Number 6, the Mercedes-Benz CDI, OM611 and OM612. Before Mercedes-Benz pivoted toward AMG performance numbers and lifestyle branding, their engineers in the late 1990s were methodically building a common rail diesel family around one priority above all others: longevity. Not horsepower, not refinement, not throttle response, service life. The OM611 in 2.2-liter form and the OM612 in 2.7-liter 5-cylinder form are engines that Mercedes' internal technical documentation rated at 600,000 kilometers, 372,000 miles, at design load. That number exists in engineering records, not in marketing copy. The Bosch Common Rail system, running at pressures up to 26,000 psi, ensured complete fuel atomization at every combustion event, which is what allows the engine to run clean enough to not destroy itself through carbon accumulation over hundreds of thousands of miles. On Quora, a 2004 Grand Cherokee CRD owner posted, "I drive a 2004 Grand Cherokee CRD. Bought it used in 2010. I'm still driving it. It's got 340,000 kilometers on the odometer and purrs like a kitten." That's a 14-year-old Jeep with 210,000 miles, running with the quiet confidence of a vehicle that hasn't been asked to do anything its engine wasn't designed for. The EGR valve and the intake swirl flaps need proactive attention. Same story as the M57. Same discipline required. The engine block itself will outlive your patience for the supporting hardware, and that's the trade-off Mercedes deliberately accepted in the design phase. Now here's what the number 1 engine on this list has that none of the 6 engines we've covered can claim. Its fuel system has no electronic components whatsoever, which means there's nothing to recalibrate, nothing to fail a sensor test, and nothing a scan tool can misdiagnose. The implications for long-term simplicity and cost of ownership are not subtle.
Number 5, the Ford 7.3-liter Power Stroke. Here's a number worth pausing on. Approximately 2 million Ford 7.3-liter Power Stroke engines were built between 1994 and 2003. That production volume, across 9 model years, against Dodge's Cummins and GM's diesel offerings of the same era, says something very specific about how thoroughly this engine earned its market position. International Navistar designed the V8 around a Caterpillar-licensed HEUI injection system that used engine oil pressure to actuate the injectors rather than a conventional high-pressure fuel pump. The cast iron block, forged steel internals on pre-2001 examples, and the complete absence of an EGR system or a diesel particulate filter gave this engine the mechanical breathing room it needed to accumulate serious mileage without accumulating serious problems. Picture this. You're 80 years old. You bought your 2000 Ford F-350 new and put it to work in hotshot delivery across Texas. You just rolled past 1.3 million miles. The engine is original, the frame is original, the rear end is original. That's not a forum legend. That's Mr. Freeland, documented on video on the original drivetrain. On the Ford Truck Enthusiasts Forum, one owner described his 2002 7.3 at 565,000 miles. Stock IPR working fine, stock IDM working fine. Had some coughing on the factory CPS, so it was changed, but never left me stranded. 400,000 to 500,000 miles is effectively guaranteed in an unmodified, properly maintained truck. The known failure points, the cam position sensor, the fuel filter heater, the valve cover gaskets, are all sub-$500 fixes that don't put the engine itself at risk.
Number 4. The GM Duramax LBZ 6.6 liter. Ask any diesel mechanic which Duramax they'd put in their own truck, and most won't pause long enough to feign uncertainty. LBZ. Built for the 2006 and early 2007 Chevrolet Silverado and GMC Sierra HD trucks. The LBZ landed at a precise intersection of resolved engineering problems and pre-regulatory timing. GM's truck product team had fixed the LB7 injector cracking issues that cost LB7 owners between $3,500 and $5,000 per repair cycle. They had corrected the LLY's overheating tendency that made towing unreliable in hot weather. And they accomplished both fixes before emissions regulations effective January 1, 2007, mandated diesel particulate filters and diesel exhaust fluid systems onto every heavy-duty truck produced afterward. The LBZ was the last pre-emissions Duramax, and that single historical fact drives its used market premium in 2026. On the Duramax forum, one member posted, "My buddy's 2006 LBZ has 395,000 miles on it. Still runs great, actually better than my LBZ that has 139,000 miles on it. The difference is he has had his since new and maintained it." The 6-speed Allison 1000 that debuted alongside the LBZ is its own category of durable. Consumer Reports reliability data on the 2006 to 2007 GM HD trucks places them at 4.5 out of 5. One couple documented 1.2 million miles on their LBZ-powered truck. The piston cracking threshold above 600 horsepower is real, but it exists only for the fraction of LBZ owners who've invested heavily in modifications, not for the owner using this truck as an actual truck. Clean LBZ trucks in 2026 command premiums that make newer HD trucks look like bargains on paper. The diesel community keeps paying them anyway because they understand exactly what the premium is actually for. They're paying to skip the entire emissions-era diesel reliability lottery. Number 3. The Caterpillar C15. Caterpillar builds mining equipment, construction machinery, and industrial power systems designed for environments that would embarrass most military hardware. In the industries they serve, unplanned downtime costs millions of dollars per hour.
That engineering culture does not tolerate adequacy. When they applied that philosophy to an on-highway diesel engine, the result was predictably almost unreasonably durable. The C15 is a 15.2-liter turbocharged inline-six, producing between 375 and 625 horsepower, depending on generation and tune. Laboratory testing, engine disassembly analysis, and years of documented fleet data put the C15's service life at 1 million miles with Caterpillar's recommended maintenance schedule, not as a marketing claim, as the documented average across thousands of fleet units. On Trucker's report, one trucker posted, "My 97 Kenworth with a 3406E had over 1.5 million miles on it when I sold it, and it had never been rebuilt. We also have an '05 Freightliner with a 475 C15. It has almost 1 million on it, and it has never been touched. Very reliable engine." Let that sink in for a second. A 2005 engine, nearly 1 million miles, untouched. The modular block architecture made field service genuinely accessible, which meant maintenance actually got completed on schedule in working environments, rather than deferred until something became urgent. That maintenance discipline fed the mileage numbers, and the mileage numbers fed the reputation. Caterpillar exited the on-highway engine market in 2010, a decision made under then-CEO Jim Owens in response to EPA emissions mandates that Caterpillar determined were too complex and costly to meet without compromising the engine's core reliability. The industry lost one of its most dependable diesel engines, not because of a mechanical failure, but because of regulatory economics. The engines built before that exit are still working today, and they're still being rebuilt, because nothing built since does the same job for the same operating cost.
Number 2. The Mercedes-Benz OM117. Ferdinand Piëch designed the OM117 while still at Mercedes-Benz in the early 1970s before he moved to Audi and ultimately transformed Volkswagen Group into the company that dominated Le Mans for years. Piëch didn't design things to be adequate. He designed things to be architectural arguments about what engineering could accomplish when nobody was cutting corners to save money. The OM117 is a naturally aspirated and turbocharged 5-cylinder diesel fitted to the W123 sedan, the S-Class W116 and W126, and the early G-Wagon from the mid-1970s through the mid-1980s. 125 horsepower in turbocharged form. Here's what that modest number conceals. A cast-iron block operating at compression ratios that would destroy less carefully designed cylinder walls. A Bosch mechanical injection system with no electronics to fail. No high-pressure fuel rail to crack under pressure cycles. No particulate filter to regenerate. No EGR system to choke the intake with carbon. The compression ratio is 21:1. The injection pump is timed by gears, not by a belt. There is, in mechanical terms, almost nothing on this engine that has a calendar-based service life. Members of the Peach Parts Mercedes-Benz Forum, the most authoritative OM117 community on the Internet, routinely discuss vehicles at 400,000 and 500,000 miles as ordinary used car purchases. One member posted about their 1983 OM117 with a confirmed 400,000-plus miles, framing it as a casual mechanical question, not a milestone worth celebrating. That's the baseline. The documented extreme reported by Jalopnik belongs to a taxi driver in Thessaloniki, Greece, who accumulated 4.6 million kilometers on a W115 fitted with this engine family. CarBuzz separately recorded a 2.4-liter W123 taxi in Spain at 4.3 million miles. These were working taxis, not museum pieces, running on local diesel of variable quality in climates and on roads that modern press fleets never encounter. The injection pump timing drifts over decades and benefits from recalibration on high-mileage examples. That is the complete intervention list. The engine that PX designed in the early 1970s is still setting mileage benchmarks that engines built 50 years later can't touch.
Number 1. The Cummins 5.9-liter 6BT. No electronics to fail, no emission system to choke it, no complexity to betray you at 400,000 miles. The Cummins 5.9-liter B-Series 12-valve, produced from 1989 through 1998, is the engine against which everything else on this list is measured. Not because it's the most recent, or the most powerful, or the most technologically sophisticated, but because 35 years of owner data say so without ambiguity or exception. The Bosch VE rotary mechanical injection pump on the early trucks and the legendary Bosch P7100 inline injection pump on the 1994 through 1998 trucks. No electronic fuel control, no sensors to fail intermittently, no engine control module to corrupt after a power surge. If the pump turns and there's fuel and air, the engine runs. That's the entire operating logic. The forged steel crankshaft is secured by 14mm main cap bolts borrowed directly from Cummins commercial truck specifications. The connecting rods are forged I-beam units with 1.57-inch floating wrist pins, individually capable of surviving 1,400 horsepower in built drag applications. Those same rods live in a stock truck making 160 horsepower. That engineering margin, the deliberate, expensive, structural overbuild, is the entire story. On Cummins Forum, one member posted about their 1991 work truck. "We have a 91 Cummins that was bought with $600,000 and now has $1.3 million. Oh, and only 3 trans changes and no engine rebuilds. Kinda tired now." Another member, "I have over 350,000 miles, no rebuild, no overhaul, and I sled pull the hell out of it." Another, "My 97 has 394,482. It's stock and hasn't been touched." These aren't exceptional trucks. They're normal trucks with oil changes and nothing else extraordinary. EcoCar Solutions research found that diesel-powered heavy-duty pickups took 8 of the top 10 trucks most likely to exceed 250,000 miles, and the first-generation Cummins is the direct ancestor of every diesel truck that built that statistic. Every competent mechanic in North America can service the 6BT with tools already in the shop. No laptop, no dealer software, no proprietary scan tool. The Bosch VE and P7100 pumps both have comprehensive aftermarket support across virtually every market on Earth. When emissions regulations forced Cummins toward electronic controls and common rail injection through the late 1990s and into the 2000s, the 5.9 gained power and compliance and slowly began negotiating away the mechanical purity that made the 12-valve indestructible. The version that makes the least power on paper is the one with the longest documented lifespan in the real world. An engine built deliberately without electronic complexity doesn't accumulate failures because of complexity it doesn't have. That's the list. 10 diesel engines that, properly maintained and fed clean fuel, will outlast almost everything built since. Here's the question I want answered in the comments. Which of these engines have you actually owned? What mileage did you reach? And what was the one repair everybody warned you about that never actually happened? The collective ownership data in the comments on this channel is more accurate than any reliability survey a magazine has ever published, and I read every comment that comes in. If this video saved you from buying the wrong diesel, hit subscribe so the next one finds you. If you want to see vehicles that made automotive history in ways nobody anticipated, check out my video on the weirdest cars ever featured in movies. The stories behind how they ended up on screen are every bit as surprising as the engines on this list.